Okay, we're going to go ahead and do rational exponents, unit 3.3. Again, rational is just fractions, and of course, exponents, we know what those are. Um, so a couple exponent rules to review. The first one is the um, a that's raised to a power, which is in turn raised to a power like this right here, a to the n raised to the m. So the rule for that is a power raised to a power is that you multiply those two exponents. And so to give you an example of how this is going to work, for example, if we take the square root of 2 squared, we know the square root cancels with the squaring inside, and the answer comes out as 2. Well, understand that if I take 2 squared and I raise it to the 1/2 power, that based on the rule that I just talked about over here, that 2 times 1/2 is 2 over 2, which is 1, which gives exactly the same answer of 2 as we got by taking the square root of 2 squared. The point is that the rational exponent is exactly the same as the square root. And the way this works, I'll explain it right down here. So the numerator represents the power to which the base is raised. And we'll get to that in a minute. The denominator represents the root being taken of the base. So 1/2 as a exponent is a square root. 1/3 would be a cube root. 1/4 would be a fourth root, so forth. The numerator would be squaring what's under the radical. So for example, if I had 2/3, I'd be taking the cube root based on the denominator, and then I would take that answer and square it. So we'll take a look at some examples. Okay, so here uh, you see that you have x raised to the 3/2. Then they say that's equivalent to the square root of x cubed. Again, the denominator is the root. There's an implied 2 there. And 3 is what the base is being raised to. Now, notice that they do it two different ways. You can cube the radicand first and then take the square root, or you can take the square root first and then raise it to the third power. Either way, you get the same answer. The preferred way is almost, it always seems to be this is the better way to do it. But just to show you an example, let me start to reveal some of what's behind here. And so you can see I've done two versions of the same problem. So if I take 4 and raise it to the 3/2, if I do it the first way that they showed here, I can see that take the square root of 4 cubed. Well, I could do 4 cubed first and get 64 and then apply the square root, and I would get 8. Or, same problem, I can take the square root first of 4 and then take that answer and cube it. The square root of 4 is 2, 2 cubed is 8. So you can see that either way, I am getting exactly the same answer. Okay? So these examples here, y to the 5/6, all you're doing is rewriting it using radical notation. And there's going to be a reason that you're going to flip-flop between these two versions, depending on what it is that you want to accomplish. So you'll be doing translations in both directions. So again, y to the 5/6, the sixth is the root, 5 is what you're going to raise it to. And again, this could also be rewritten as the sixth root of y. And then after you've taken the sixth root, you could raise it to the fifth power. Those are equivalent. Okay, and likewise, you could see, I'm not going to explain every one of those. Okay, so if they asked you to simplify 16 to the 3/2, well, the way I would do it is I would take the square root of 16 because of the denominator of 2, and then cube that answer. So the square root of 16 is 4. 4 cubed is 64. So the answer to that would be 64. -8 raised to the 1/3 is going to be minus. I've got the negative sign underneath there, but really technically, um, to include that negative sign on the inside, I really should have had that in parentheses. So if you want the negative sign included with what's under the radical, um, you would have it in parentheses. And so this probably really isn't correctly written. I should have the negative sign out front. Either way, I'm going to get the same answer because taking the cube root of a negative number is okay. So the cube root of -8 is -2, which we've discussed previously. And then 125 raised to the 4/3, that means I'm taking the cube root of 125 and then I will raise it to the fourth power. Cube root of 125 is 5, 5 to the fourth is 625. Okay. So it's when you're doing operations on radicals, it's easier to use the rational exponents. And so these examples, I'll take it from the radical form into the form that uses the rational exponent. Okay, so these are just converting in the other way. So the square root of x, x to the 1/2. The cube root of y squared would be y raised to the 2/3. Again, the bottom number, the denominator is the root. And the sixth root of z to the fourth would be z to the 4/6. That reduces to 2/3. Okay, so if I was to convert all three of these to their equivalent form, I'll just go ahead and delete the block. The square root of b cubed, b to the 3/2, and likewise the cube root of 8y cubed would be this. Now, if they want you to simplify it, I could apply the cube root of 8, which is a 2, but they're just asking to rewrite it. Okay, so another exponent rule that you've got to know, because we are dealing with rational exponents, is this rule right here. So if I am multiplying the same base with exponents, then the rule is I'm going to keep the base, I'm going to add the exponent. So here's an example right here. We have a base, common base of 5, and one is raised to the 5/6, the other to the 7/6, and I'm multiplying them. That means what am I going to do? I'm going to add the exponents. And remember, when you add or subtract, you have to have a common denominator. This is a common denominator. And so the result will be 5 raised to the 13/6 power. Okay, this next one here, if you rewrite these with fractions, rational exponents, you're going to see that I have different denominators, right? So let me clear this out a little bit. So I have x to the 4/5 for this first one, and that's multiplying x to the 1/2. Okay, well, 5 and 2 are not common denominators, so the common denominator will be 10. So I will go ahead and here's the fraction problem I'm solving for the exponents. So a common denominator of 10 means both of these fractions get rewritten to 8/10 plus 5/10. When I add it, I get 13/10. So the final answer in this case will be x raised to the 13/10. Okay. Here's the power rule that we've already talked about. A power raised to a power is we multiply the exponents. Okay, so I'm not going to go in great detail. I think you'll be able to work these out, but let me go ahead and just clear out some of these. So if I multiply 1/4 times 2, I get 2/4, which simplifies to 1/2. So that's 16 to the 1/2. But if I've got to simplify it, then here's where it becomes easier to turn it into radical notation. And so that is just the square root of 16, which is 4. Okay, the next one, I'm just going to multiply 3/4 times 2/3. I won't be able to simplify since it's just a y. And so when I multiply 3/4 and 2/3, I get 6/12, which reduces to 1/2, which means it's just the square root of y. Okay, and again, I'm just going to start to drop the boxes. I'm just multiplying the exponents. So you can pause this video anytime you want. Now, I am applying a rule here that I guess they haven't talked about. So let me write this rule out real quick here. So I think I have it written later, but I'll do it again now. But if I have multiple things being raised to a power, then I distribute that exponent in onto everything on the inside. So that's an n. Okay. So this 7/2 comes in on each of these and multiplies. So it'll be g to the 18th times 7/2, a to the 10th times 7/2. So those exponents just all multiply each other. And I end up with g to the 63rd, a to the 35th. Okay, so this one here, the 1/5, fifth root comes in on the 32, and it also comes in on the q that already has an exponent. So when bringing this exponent in, I get 32 to the 1/5, and q, when I multiply 5/7 times 1/5, I get 5/35. Well, 32, the fifth root of 32 is 2, and so the simplification would be 2, and they may keep it as q to the 1/7 or the seventh root of q, same thing. So the 32 did simplify, taking the fifth root. Okay, the quotient rule, when you're dividing, if again, you have to have the same base. If you have the same base and you're dividing, you subtract the exponents, okay? And so this first example, we have the same base of x. We have 5/3 on top, 2/3 on the bottom. The rule says we just go ahead and subtract those exponents. So when you take 5/3 minus 2/3, you get 3/3, which is 1. So that just means that this is x to the first, or just x. Again, what am I going to do? I'm going to subtract 3/4 minus 1/2. I need a common denominator of 4. So there's the math problem I'm solving with the exponents. So that's going to be 3/4 minus 2/4, which is 1/4. So this is really the fourth root of 16, because it's 16 to the 1/4. Well, the fourth root of 16 is 2. And again, if you weren't sure how to do that, you could take 16 and raise it to the 1/4 power, and you will get the answer of 2. Okay, so the first thing to do here is, if I want to do the division, you see I do not have common indexes. So this is where it becomes really mandatory to put these things with rational exponents. So I'm going to rewrite this as x to the 1/2 over x to the 1/3. And now the rule says subtract those exponents. Well, I need a common denominator of 6. So there's my math of 3/6 minus 2/6 when I convert them to a common denominator. And that is 1/6. So it's x to the 1/6 or the sixth root of x. And just look at the instructions as to how they want you to answer it. If you're doing problems like this, it may be perfectly fine to leave it as x to the 1/6. Here we got to apply a couple rules, right? So in the numerator, they all have a base of q. I can go ahead and add these exponents together, and then that'll give me q to the 9/5 over q to the negative 1/5. And this is where you need to be careful. When I subtract, because we're dividing, 9/5 minus a minus 1/5 is really a plus. So here's the math. I'm subtracting a negative, which turns into addition. So when I add the exponents, I get 10/5, which is equal to a 2. So the simplified answer is going to be just 2 to the second power. Here's a little bit of a challenge question. First thing I would do is I would distribute the 1/2 in, or the square root in. Well, the 25 to the 1/2, the square root of 25 is 5. So there's my 5. x to the 1/2 comes in, and then I'm going to multiply that by a -2. The -2 does not have an exponent on it, so it's just going to multiply ultimately that 5 to end up being -10, and then I have x to the -3/4. And now what do I do? When I multiply the x's with the same base, I'm going to add the exponents, but I need a common denominator, right? And so 1/2 minus 3/4, I'm kind of not showing all the work here, but 1/2, the common denominator of 4 would be what? 2/4. 2/4 minus 3/4 is a -1/4. This right here is probably fine to answer it, I think, in the homework, just leaving the negative exponent. But a negative exponent, one of the rules for negative exponents are that you move it to the opposite side. So since this is in the numerator, equivalently, this could be -10, because the x is the only thing with a negative exponent, and you can move the x to the denominator and make it a positive exponent. So these two are equivalent, but I do believe that this will be perfectly acceptable. Just an example problem of how something like this could get used. So here you got the formula for computing an interest rate, giving some information. P is the present value, or the principal, that's what you put in. The A represents the future amount, what it grows to. And then T is time in years. And so here's the information that was given to us in the problem. What do? You simply plug it into the formula. So there's the values plugged in, and then I would do the division of 6894, divide that by 5,000, and then raise it to the 1/6 power, and then subtract 1. I get that as a decimal. And so as an interest rate, and this is the decimal equivalent, it would be 5.49%. So pretty simple, just substitute in and just work your calculator. Here's another one. I'll pause it. I'm just going to go ahead and click out of it. Let's see if you get the same answer. Ultimately 6.49%. Just substitute in the values. Here's some mixed practice. Just remember on this first one that the 4/3 goes to the 27 and it goes to the x. So the cube root of 27 to the 4th power written here. So the cube root of 27 is 3. 3 to the 4th power is 81. And then when you multiply those exponents, you get 4/12, which produces to 1/3. Okay, so I'm just going to go ahead and click all these boxes, and I'll want you to work the problems and then take a look and see if your solutions match. And I'm going to scroll down, so again, pause if you need to. And then here are the remainder of the problems. Again, check and see that your results match. Okay?